Alright, so the first thing we want to look at are questions like this. List the factors of 18. So to factor a number, of course, means to write it as a product. And when we write a number as a product of something times something, then those two things that are being multiplied are called the factors. So to factor 18, basically you're looking for two numbers that multiply to equal 18. So for instance, we could start real simple, and this is the most obvious one that shows up for every number. 1 times 18 is 18. But we could also do this. 18 equals 2 times 9. To keep things kind of orderly, notice what I've done. I started with a 1 and then I went up to a 2, and it just so happens that 18 is 2 times 9. And then we have, is 3 a factor? Well, yes, 18 is 3 times 6. And that's as far as we can go. 4 doesn't factor into 18, and then 5, and then when we get to 6, well, we can see that if we get up to 6, well, if we're going to use 6, it's just 6 times 3, which we've already got. 3 times 6 is the same as 6 times 3, of course. So these are the factors of 18, those 6 numbers. So when we talk about factors, the other thing that we often talk about is writing the prime factorization of a number. So write the prime factorization of a given number. So if we want to use 18 again, basically the prime factorization is we start by factoring the number, and we can actually pick any of the factoring pairs that we have up here. And so we're going to say, okay, 18 is 2 times 9. And then what we want to look at is those two factors, the 2 and the 9, and see if they can be factored further. The 2 cannot be factored into anything besides 1 and 2. So it is a prime number. 9, on the other hand, can be factored into 3 times 3. Now notice, each of these numbers is a prime number, and you remember that the prime numbers are the numbers that are bigger than 1 and that only have factors 1 and themselves. So 2 times 3 times 3 is the prime factorization of 18. We have broken 18 down into its constituent parts. Alright, so let's try one more. Let's try, say, 60. Now I'm going to do this a slightly different way, because sometimes you might be used to doing it like this. You might create what's called a factor tree, and you can say, okay, 60 is, I don't know, it really doesn't matter where you start, just find any two numbers that multiply to give you 60. So in this case, 6 times 10 seems to make sense, because 60 is a multiple of 10. Then you look at the 6 and ask, can it be factored further? And it can. It can be factored into 2 and a 3. 2 times 3 is 6. And do the same for 10. 10 can be factored into 2 times 5. And now we see that our factors are all prime numbers, and you might want to review for a moment what prime numbers you remember, up to about 20. But look, those are all prime numbers, 2, 3, 2, 5, and so we can say 60 is equal to 2 times 3 times 2 times 5, right? There's our 6 and there's our 10. Or if we rearrange this, which we can do, put all the, go kind of from smallest to largest, we get 2 times 2 times 2 times 3 times 5. And then if we even get a little more concise, we can take those 2's and write them as 2 squared, and that's the prime factorization of 60. Now let's try a problem that's a little bit harder here, a prime factorization problem that's a little bit harder, not using a number that is quite so simple. And so let's try 297, for example. Alright, so the question is, we would like to factor that, find its prime factorization, and so the first thing you have to do is find any way to factor it, find any pair that factors and gives you 297. So of course you look at this number and you say some things just kind of in your head. You say, okay, I know 2 is not a factor because it's not even. 297 is not even. I might also say, I know 5 can't be a factor because the number doesn't end in 0 or 5. Those are kind of two of the most common known tricks. Let me share one other trick with you, and it has to do with the number 3 and determining if 3 will divide evenly into 297. And the trick is simply this: you add up the digits of 297. So 2 plus 9 plus 7. 2 plus 9 is 11, plus 7 is 18. Right? 2 plus 9 plus 7 is 18. And then you ask, is that number divisible by 3? And if it is, then 297, or your number, is divisible by 3. So 18 is divisible by 3, and so 297 is divisible by 3. So that's important because that gives us a place to start. We can say, all right, we know 297 is one of the factors, so at the very least we can start breaking it down like this. Or 3 is one of the factors of 297. So 3 goes into 297 how many times? And we might have to do some old-fashioned long division, right? Divide 3 in there. 3 is going to go in there 9 times. Multiply. 9 times 3 is 27. Subtract is 2. Bring down the 7. How many times does 3 go into 27? That's, of course, 9 times, with a remainder of 0. So we know that 3 goes into 297 99 times, so we can write 297 as 3 times 99. Now remember, we're trying to find the prime factorization of this. The good news is 3 is a prime number, so we don't have to worry about breaking that down any further. But what about 99? Well, it shouldn't take us too long to realize, hey, that's 9 times 11. And then the good thing is 11 is a prime number, so it doesn't need to be broken down. That leaves 9, which of course is 3, which are both prime numbers. And so those 4 numbers form the prime factorization, and that's 3 times 3 times 3 times 11, or 3 raised to the 3rd power times 11. That's the prime factorization of 297.